We have a function f of x is equal to the absolute value of log base 10 of x plus 1. Real numbers a and b satisfy these two equations, and our job is to find what a and b are. So there's not much to this problem besides just substituting our values into our given conditions. So f of a, it would be equal to absolute value of lg a plus 1. F of negative b plus 1 over b plus 2, that would be equal to absolute value of lg 1 minus b plus 1 over b plus 2. So when we further simplify, we get lg 1 over b plus 2. And we are told that these two expressions are equal. We're saying that 10 to some value gives us 1 over b plus 2. If we did 10 to the negative x power, we would just get b plus 2. But in this case, x and negative x both have the same absolute value. So we can just rewrite this absolute value as lg of. From here, we can think of two different scenarios. The first scenario is that a plus 1 and b plus 2 are actually equal to each other. They are the same argument. Another scenario is if a plus 1 and b plus 2 are reciprocals of each other. It's because the exponent that was used to get to these two arguments had the same absolute value, but one was positive, one was negative. So in our first scenario, a would be equal to b plus 1. But we said earlier that a must be less than b. So this scenario would not work for us. Let's stop here for now, and we can focus more on our next condition we haven't used yet. F of 10a plus 6b plus 21 is equal to the absolute value of the log of this expression. This is equal to lg 16, because we can move the coefficient of 4 over the 2 to make it 2 to the 4th power. And so here, when we have a plus 1, we know that it must be greater than 0. It's because a plus 1 appeared earlier here, and we know that the argument of a logarithm must be greater than 0. We also know that because a is less than b, a plus 1 is less than b plus 1. And what about b plus 2? B plus 2 must be greater than 1. This is because we know that b plus 1 is greater than 0, so b plus 2 must be greater than 1. Now, how can we manipulate the inside of this logarithm? Well, it is equal to 10 times a plus 1 plus 6 times b plus 2. We know that a plus 1 is greater than 0, and b plus 2 is greater than 1, which means that this inner value is greater than 6. So now we have to differentiate whether this expression is equal to 16 or 1 over 16. Well, because we know that this expression has to be greater than 6, it means its value is 16. It cannot equal 1 over 16. And taking an equation from earlier, we can make a system of equations. We know that a plus 1 from here is equal to 1 over b plus 2. There are two equations and two variables, which means now we can solve for both a and b. Now we can factor our quadratic. We see that 3b plus 1 times b plus 1 must be equal to 0. So b can be equal to negative 1/3 or negative 1. However, we said that b plus 2 must be greater than 1. This means that b must be greater than negative 1. So b cannot equal negative 1, which means that b is equal to negative 1/3. And we can substitute b in here. A is equal to 1 over 2 minus 1/3 minus 1. this is equal to 1 over 5 over 3 minus 1. So A is equal to -2/5. And that is the answer to our problem.